Let's see some unit circle examples. Example 1. Find sine of 30 degrees and cosine of 30 degrees. From the unit circle, we know that the coordinate at 30 degrees is the square root of 3 over 2, comma, 1/2. So, sine of 30 degrees equals 1/2, and cosine of 30 degrees equals square root of 3 over 2. Example 2. Find the exact value of tangent of 225 degrees within the interval from 0 degrees to 360 degrees. Solution. 225 degrees is in the third quadrant, where both sine and cosine are negative. The coordinates are negative square root of 2 over 2, comma, negative square root of 2 over 2. Using the formula, tangent of theta equals sine of theta divided by cosine of theta. Tangent of 225 degrees equals negative square root of 2 over 2, divided by negative square root of 2 over 2, which simplifies to 1. Example 3. Solve for all values of theta in the interval from 0 degrees to 360 degrees, where cosine of theta equals negative 1/2. We could just look at the unit circle to find where cosine of theta equals negative 1/2. But instead, let's go step by step to understand what's really happening. Cosine represents the x-coordinate on the unit circle. Since cosine is negative, we know the angles must be in quadrants 2 and 3, where x values are negative. Next, we find the reference angle by solving cosine theta equals positive 1/2. From the unit circle, we know that cosine of 60 degrees equals 1/2. So, the reference angle is 60 degrees. Now, we use this reference angle to determine the actual angles in the correct quadrants. In quadrant 2, angles are measured from 180 degrees going backward. So, we subtract the reference angle from 180 degrees. Theta equals 180 degrees minus 60 degrees, which is 120 degrees. In quadrant 3, angles are measured from 180 degrees going forward. So, we add the reference angle to 180 degrees. Theta equals 180 degrees plus 60 degrees, which is 240 degrees. Final answer. Theta equals 120 degrees and 240 degrees. So while we could have just checked the unit circle, now we fully understand why these are the correct answers. Example 4. Find the exact value of sine of 135 degrees. Solution. 135 degrees is in the second quadrant, where sine is positive. To find the exact value, we first determine the reference angle. The reference angle is the smallest positive angle between the given angle and the x-axis. It is always positive and less than 90 degrees. To calculate the reference angle for 135 degrees, we subtract it from 180 degrees, because angles in the second quadrant are measured from 180 degrees. Reference angle equals 180 degrees minus 135 degrees, which is 45 degrees. Since sine of 45 degrees equals square root of 2 over 2, the value of sine 135 degrees is also square root of 2 over 2. Example 5. Solve for all values of theta in the interval from 0 degrees to 360 degrees, where sine of theta equals negative square root of 3 over 2. Solution. Sine is negative in quadrants 3 and 4, so we know our answers must be in these two quadrants. To find the reference angle, we ignore the negative sign and look at the positive value. Sine theta equals square root of 3 over 2. From the unit circle, we know that sine of 60 degrees equals square root of 3 over 2. So, the reference angle is 60 degrees. Now we use this reference angle to determine the actual angles in quadrants 3 and 4. In quadrant 3, angles are measured from 180 degrees going forward. So, we add the reference angle to 180 degrees. Theta equals 180 degrees plus 60 degrees, which is 240 degrees. In quadrant 4, angles are measured from 360 degrees going backward. So, we subtract the reference angle from 360 degrees. Theta equals 360 degrees minus 60 degrees, which is 300 degrees. Final answer. Theta equals 240 degrees and 300 degrees. If you found this helpful, don't forget to like, subscribe, and click the bell icon for more tutorials. Thanks for watching and see you next time.